Alright, we're moving on to dividing real numbers. And hopefully you'll see that this has a very nice connection to multiplying. If you recall, we talked about subtraction and how well that corresponds with addition. And something similar happens here with division. Corresponds quite nicely with multiplication. One place you see that is looking at the sign. At the sign of a quotient. Quotient, of course, means that we have division going on. So the quotient of two real numbers with the same sign is positive, just like multiplication. Multiply two numbers with the same sign, you get a positive result. The quotient of two real numbers with different signs is negative. And then the quotient of 0 and any non-zero real number is 0. Remember that we cannot divide by 0. So what we're looking at here would be something like 0 over a. Okay? So if a is any real number other than 0, so a not equal to 0, then our result is going to be 0. Okay? Other than that, these two rules apply. So same sign positive, opposite sign negative. Remember, that's for multiplication and division. Okay, speaking of the connection to multiplication, we're going to look at the inverse property of multiplication. And this tells us that if we take a non-zero number and we multiply it by its multiplicative inverse, we get 1. That's a definition of a multiplicative inverse. So whatever you take times a to get 1, that's the multiplicative inverse. And we're going to get that by, in the case of, let's say, a whole number or an integer, we'll get that by putting it underneath a 1. You'll see something different in the case of fractions, as in our examples here. Again, a cannot be 0 because we cannot divide by 0. So examples would be, if you start with 7, multiply times 1 over 7, so we're inverting this, putting it underneath a 1, that will give you 1. If you take 3/4, its multiplicative inverse is 4/3. So you might hear the expression invert or flip it, because you've taken that 3/4 and you flipped it in sense of the denominator now becomes the numerator and the numerator becomes the denominator. And again, that will equal 1 when you multiply those. What about a negative? Well, if you take negative 2/5, again, invert it to get 5/2, but then also make that a negative so that we end up with a positive 1 as our product. Okay, the division rule tells us that if, again, we cannot divide by 0, but in order to divide by a number b that's not 0, we can simply multiply by its multiplicative inverse. Okay, so for example, if we want to take negative 8 divided by 2, of course you can already do this. This is not real complicated in this case, but just for exercise, know that this is the same thing as negative 8 times the multiplicative inverse of 2 is 1/2. Okay, you might have already learned how to divide fractions using this method. Hopefully that will look familiar. Okay, something that shows up along here talking about division is the idea of finding the mean. Now, a lot of times people say average when what they're really talking about is the mean. And of course we find the mean by adding all the numbers in a set together and then dividing by however many numbers there are in that set. So as an example, here if we want the mean of negative 8, 2, and 12, we add those three together, negative 8 plus 2 plus 12, and then we divide by 3 because there are 3 numbers in the set. And that will give us 6 over 3, which we simplify to 2. Alright, simplifying a quotient. Remember that we can rewrite a quotient as a product of a dividend and the multiplicative inverse of the divisor. You do remember those terms, right? Dividend and divisor. You'll see that in a moment. Okay, so this can help simplify a fraction, and this is especially going to be true if you have some common factors, so you can do some simplifying. So here's an example. Okay, so here's the dividend is 8x minus 6. The divisor is 2. So we're dividing by 2, that's the divisor. We can take that dividend, 8x minus 6, and instead multiply by the multiplicative inverse of 2, so times 1/2. Okay, so we have 8x minus 6 times 1/2, use the distributive property, and we can rewrite that as 8x times 1/2 minus 6 times 1/2, and we end up with 4x minus 3. Okay? Now, as you get more comfortable with this, you'll see some other things that happen here. For example, notice that 2 is a factor of 8 and of 6. Okay, so you can actually simplify here, but you have to be very careful when you're doing this, because if you're going to simplify the 2 here in the denominator, in other words divide by 2, you have to make sure you divide every term in the numerator by 2. And that's what happened here. If you take 8x divided by 2, you get 4x, and then negative 6 divided by 2 will give us negative 3, or subtracting 6 divided by 2, subtracting 3. Alright, let's look at some examples. Find the multiplicative inverse of the number. So we're looking for what number times this will equal 1. Okay, so here in the case of a fraction, we simply invert. So instead of 2 over 3, it's going to be 3 over 2. So 3/2 is the multiplicative inverse of 2/3. In the case of 7, if you want, you can rewrite this as 7 over 1, which might help you see how to form the multiplicative inverse. Invert that to get 1 over 7. Okay? Now here we have a mixed number, so we need to convert that to an improper fraction. So we're going to take 5 times 6 plus 2. So 5 times 6 is 30, plus 2 is 32 over 5. And now we can take the inverse of that is 5 over 32. Okay, so if you multiply 6 and 2/5 times 5 over 32, you'll get a result of 1. Negative 1/8 is going to be, well, of course we need a negative, and again, if you want, you can write this as 8 over 1, and now simplify that, of course, to simply negative 8. Right, next few problems, find the quotient. So here we're going to apply our rule of division. So we have 4 divided by negative 2, and of course opposite signs, so positive and negative will be negative. 4 divided by 2 is 2. If you want, you can set that up as 4 times negative 1/2. In this case, I don't think it's really necessary. Here again, you have 20 and 5. 5 goes into 20 evenly, so really we can just leave it like this, but pay attention to your signs. So negative divided by negative is positive, 20 divided by 5 is 4. Here, we're dividing by a fraction, so you might want to go ahead and use that rule where we can multiply by the multiplicative inverse. So this is going to be equal to negative 3 times, and then instead of 1 over 4, 4 over 1, which of course is just 4, and negative 3 times 4 is negative 12. Okay, so negative times a positive gives us a negative. Alright, number 8. So here we have 2 mixed numbers. We want to go ahead and convert those to improper fractions. The good sign in this case is that we have positive and positive, so our answer is positive. We don't have to deal with any negatives. So convert this to an improper fraction. 3 times 5 is 15, plus 2 is 17, so 17 over 3, divided by, then 4 times 2 is 8, plus 3 is 11 over 4. Okay, and then we can rewrite that as 17 over 3, and then instead of dividing, multiplying times invert to get 4 over 11. Okay, now can we do any simplifying? In some cases you might prefer to simplify even before you carry out the multiplication. But in this case, there is no simplification because 3 is not a factor of 17 or 4, and 11 doesn't go into 4, obviously, or to 17. So there is no simplifying here. So we're going to have 17 times 4 in our numerator and 3 times 11 in our denominator. 4 times 17 will give us 68, and then 3 times 11 will give us 33. Now, I would suggest you simply leave it like this. You can convert it to a mixed number, but really I suggest that you get more and more comfortable working with fractions, including improper fractions. Okay, next type of problem. Find the mean of of 2, negative 3, 0, and 9. So first of all, we have to add these together. So 2 plus negative 3 plus 0 plus 9, and then we're going to divide that by the number of numbers. So we have 4 members in this group, so we're going to divide by 4. Now notice the 0 does not impact the sum here, but it does affect the mean because it's included as one of the members that we're dividing by. Okay, so if we start with 2 plus negative 3, that's negative 1, plus 9 is 8, and divide by 4, and of course we can simplify that to simply 2. Now this is not always going to be a whole number or an integer. I would expect to see some decimals and or fractions here from time to time. Okay, number 10, simplify the expression. So in the next 3 problems we have a quotient, and of course we can rewrite this as, so we take our dividend, 4x plus 12, and then multiply by the multiplicative inverse of our divisor, so times 1/2. Okay, so half of 4x is 2x plus, and that is a dot, not a negative, half of 12 is 6. So this can be simplified to 2x plus 6. Notice again, 2 does go into both 4x and 12. So if you take 4x divided by 2, 12 divided by 2, you'll get the same result here. Okay, so same idea here, 12y minus 16. And we're going to multiply times negative 1/4. So if we take 12, really we're dividing by 4 in effect here, but it's a negative. So negative 12 divided by 4 is 3, of course, so negative 3y. And then we have minus, but now we have 16 times negative 1/4, so that's negative 4, which we're going to rewrite now as negative 3y plus 4. So subtracting negative 4 is same as adding 4. Okay, number 12. So notice here, 4 goes into 12. It does not go into 22. So we will get a fractional part here. So this is equal to negative 22 minus 12q. We're going to take that in parentheses times positive 4 inverted will give us 1/4. Okay, so now negative 22 divided by 4, that's going to be a negative. And for now, I'm just going to write this as 22 over 4. And then minus 12q divided by 4. Well, 12 divided by 4 is 3, so 3q. And then I'm going to simplify that fraction, because even though 4 doesn't go into 22, we can divide each of these by 2. So this is equal to negative 22 divided by 2 is 11, and 4 divided by 2 is 2. So negative 11 halves minus 3q. Right, so good luck again with your division, and pay attention to those signs.